Okay, hi everyone. First, MSU Denver would just like to acknowledge that the Indigenous people and land of Aurora and broader Denver area, we would like to recognize that the land we're on, speaking about, and working with today are the traditional territories and ancestral homelands of the Cheyenne and Arapaho nations. This area was also the site of trade, hunting, gathering, and healing for many other Native nations, the Lakota, the Ute, Kiowa, Comanche, Apache, Shoshone, and others. Thank you. So we are the MSU Denver team. My name is Hermela, and I'll be working and presenting alongside Angela, Erin, and Kaya with the help of our faculty mentor, Sylvia Brady. And today our research will be looking at air quality data and transportation-related emissions in Denver, Colorado. And so vehicle transportation contributes to air pollution, poor air quality, greenhouse gases, health concerns, and impacts the quality of life for all citizens. These impacts include increased time in traffic, economic impacts on tourism and business, and adverse health effects. The transportation sector alone is the largest contributor to greenhouse gas emissions, and its role in emitting greenhouse gases is increasing daily. The ecological effects this can have include a decrease in food and water supply, higher temperatures, and an increase in extreme weather events. Today, our research will be looking at answering these three questions: how have transportation emissions changed over time in Denver? What factors affect transportation emissions changes in the region? And what are transportation alternatives to single occupancy vehicles? So when we're talking about air quality in Denver, it's important to note the unique geographic location of Denver at the foot of the Rocky Mountains, which creates what's known as the temperature inversion, which traps cool air and pollutants closer to the Earth's surface, which is how we get that brown cloud. That's the picture we're looking at right now. And Denver has had issues with air quality since the 1960s, but in 1970, the Clean Air Act was passed, which required regulations of all sources of air emissions. And this greatly improved the air quality in Denver and reduced all pollutants except for ozone. This is significant because the high levels of ozone recently caused the EPA to reclassify Denver from being considered moderate to now serious non-attainment. And the EPA regularly measures AQI, or air quality index, by regulating 5 main pollutants, which are sulfur dioxide, ozone, particulate matter, nitrogen dioxide, and carbon monoxide. Our research today will be looking at the first 3 transportation-related emissions and asking if there are any potential decreases due to COVID-19 and the reduction of commuting in 2020, and what alternatives we might have available to us. So Angela will walk you all through the process of how we did this.
In the pursuit of understanding the effects that vehicle miles traveled and car emissions have on Colorado's air quality, we explored a multitude of air quality data pertaining specifically to Colorado and its various counties for trends and changes over time and space. In our efforts, we researched transportation-related pollutants and the history of air quality in the Colorado region, as well as compared transportation-related criteria pollutants to see changes over time and space. Furthermore, in our research, we focused on comparing 2019 and 2020 data to see the impact COVID-19 restrictions had on the criteria pollutants as well as the AQI. We carried out our research by using Python to read the files and used matplotlib to plot the data. Additionally, we researched and found data for alternative transportation, such as bike paths and RTD routes and stops, to better inform stakeholders. Furthermore, we used Python to read and display files using GeoPandas. The majority of our data came from free downloads on the EPA website, Denver Open Data Catalog, RTD OpenGIS data, and Colorado Department of Transportation. In order to analyze air quality trends for changes over time and space, we used the core-based statistical area data of Denver, Aurora, and Lakewood provided by the EPA. In alignment with our prediction, we found that there were a total of 274 days in 2019 that exceeded good on the air quality index, whereas in 2020, there were only 247 days that exceeded good. When put into perspective, 2019 had 27 more days of poor air quality than 2020. That's almost an entire month. As you can see on both graphs, there's a great spike in the late summer months of August and September. Next slide. In order to see if the AQI really improved during the pandemic before the fire season begun, We parsed out the months of March, April, and May of both 2019 and 2020. The data revealed that there were 66 days in 2019 that exceeded good, whereas 2020 only had 53 days that exceeded good. While there are many factors that contribute to an increase in the air quality index, such as forest fires, rising temperatures, and industrial factories, the decrease of cars on the road due to the pandemic restrictions likely contributed to the better air quality in 2020. Next slide. The shapefile presented on the left portrays the number of days in which the AQI values exceeded 100, meaning that these days exceeded moderate conditions in various counties on the air quality index. The shapefile on the right displays the highway traffic count, which is current until the final week of July. As you can see, there's a significant correlation between the more concentrated highways and where the AQI values exceeded over 100. Aaron will now be talking about our results of the transportation-related criteria pollutants.
For this project, we focused on criteria pollutants that were better indicators of vehicle emissions, such as particulate matter, nitrogen dioxide, and ozone levels in the Denver area. The EPA data sets we used could be obtained using state, county, city, and even individual air monitoring stations and were available in yearly, monthly, weekly, and daily versions. When comparing transportation pollutants, we ran into issues with site locations. For instance, readings of carbon monoxide in the Denver area featured 4 collection sites, while ozone data is compiled of 12. Note the blue map on the bottom of the screen. Locations of the site used to determine ozone readings in Denver actually come from 7 different counties spread throughout the region. This made plotting time series data difficult because of various readings from various sites, same day and pollutants that didn't have the same site data. So the first criteria pollutant we looked at was particulate matter. Particulate matter consists of fine particles and water vapor in the air and is measured at 2.5 and 10 micrometers. Sources include gas and diesel emissions, dust and debris from fields or construction, power plant emissions, and fires. Here we have side-by-side plots of the March, April, May months showing levels of good, moderate, unhealthy for sensitive groups, and the red line at the top, which is unhealthy for everyone. Our data showed the number of days that were moderate or worse had decreased in 2020. We also plotted particulate matter 10 micrometers, similar to the 2.5 data. There was an increase in average, but a decrease in the number of days that were good. The next transportation-related criteria pollutant our group looked at was nitrogen dioxide, which gets into the air from burning fuels. Plotting side by side here and running statistics in Python showed the most significant reduction of any pollutant we looked at, with a reduction in both average and number of days worse than good. However, we did see different results when we began to look at ozone. Ozone's not emitted but created when nitrogen dioxide, along with VOCs and particulate matter, react with heat and sunlight. Main contributors to ozone are exhaust from vehicles, industrial sites, power plants, and fuel vapors. Ozone becomes more of a threat during the summer months because the temperatures are higher. So for plotting ozone, we used June, July, and August data. And this is actually referred to as ozone season. As we began, we noted some news articles stating Denver had seen a significant increase in ozone levels in the past few years. Here we plotted one individual station, Welby, which is located in North Denver, during the summer months and saw a significant increase in levels from the previous year. 2019 showed 10 days above good, while 2020 saw almost 4 times as much at 37 days. Days in 2019 above moderate, there were none. 2020 had 4 days, and the average had increased from 0.05 to 0.057 parts per million. Since this trend was alarming, we decided to continue one step further and plot the data for this ozone season, 2021. In the first 58 days of this summer, data not including the month of August, 2021 has already seen 42 days worse than good and 13 in the moderate range. The 0.064 parts per million ozone concentration is almost 30% higher than just 2 summers ago. In recent weeks, Denver has some of the worst air quality in the US and top 10 worst in the world. While true out-of-state wildfires contributed to Denver's poor air, the elevated ozone levels are mainly due to Denver's unique weather patterns, summer temperatures above 85 degrees, and the rapidly increasing population, which brings more vehicles to Colorado's roads and highways. Motorists may have seen billboards on ozone alert days asking them to skip drives, mow lawns, and fuel vehicles after 5 p.m. when the daytime heat begins to fade. The Metro Denver area has a robust public transportation system, including light rail, bus, and requires single occupancy vehicles to be emission tested every 2 years. Yet the steady increases in population and temperature creates enormous challenges for Denver, the Front Range, breathable, clean air. As our project evolved, we decided it was important to create awareness and inform others about air quality index, individual pollutants, and ozone alert days because of our findings. For example, AQI is now featured on most smartphone weather apps, and in the Denver area is something that is not discussed among residents. We also hope to inform and empower others to seek alternative transportation methods, and I'll hand it over to Kaya to discuss that portion of our project. Thank you.
Here we've created an interactive Folium RTD system map showing transit options. RTD serves an area of approximately 2,300 miles with services such as light rail, FlexRide, and free shuttle service downtown. 75% of residents live within a quarter mile of a bus stop, and 10% live within half a mile of a rail station. RTD has future plans to extend rail lines, which will increase rail accessibility to the Denver metro area. Additionally, there are over 196 miles of on-street bike paths and facilities, with plans to add 270 more miles of high-comfort bikeways. There are many initiatives to encourage cycling, especially to those who commute downtown. Coffee and Commutes allows riders who live within the 7 bicycle corridors to meet at a local coffee shop and be led by a guide through the accessible routes downtown. They want to encourage residents who commute by car to consider cycling instead. With our conclusions, in our analysis and evaluation of particulate matter, we were able to conclude that between 2019 and 2020, the number of days where AQI was moderate or worse, there was a reduction in particulate matter and NO2 in 2020 compared to 2019. We also considered a separate analysis, as Aaron outlined, of ozone levels in 2020 compared to levels in 2021, specifically to see what impact stay-at-home mandates possibly had on these levels. For our future research, we will plot time series data to display a greater span of time, perhaps 5 to 10 years. We'll also need to subset the location of air quality monitoring sites to see regional effect and to show disparities in marginalized communities. We discussed creating a dashboard that would allow residents to input parameters such as vehicle type and expected travel distance that would allow them to consider alternative transportation and not use single occupancy vehicles based on the AQI that day. Electric vehicle sales have increased worldwide, according to the International Energy Agency. We would like to see how this trend impacts the Denver metro area. Denver is expected to add 145,000 more residents by 2035, and we'll need to analyze this impact as well. Until policies are implemented to reduce emissions or employers provide more incentives to encourage their employees to use alternative transport, the onus is on us as individuals to consider changing our transportation habits to reduce our use of single occupancy vehicles. On behalf of the MSU team, Aaron Doherty, Angela Carrillo, Hermela Tacabo, and myself, Kaya Roller, we want to thank you, the FLAB team, education team, excuse me. Thank you for your exemplary instruction and patience. Also, thank you to our esteemed faculty advisor, Dr. Sylvia Brady. We appreciate you sharing your knowledge and time with us. And finally, thank you to the participating schools. It was an honor sharing this experience with you all. Thank you.